All right, welcome to video 2 of the 5F1 champ build. In this video, we're going to check out the schematic and go through some of the theory, which I think a lot of people are really going to be interested in. I know Larry McDowell is going to probably dig this one, as well as Adam and a few other folks that are interested in electronics and how the stuff works. So this is one of the most simple tube amplifiers that we could talk about, which is a perfect first amp to do here on Patreon. Why don't we go ahead and we're going to break this amp up into a couple different parts. The main things in the amplifier are going to be the power supply, which why don't I go ahead and start showing you what that looks like. But sorry, before we get too far ahead, we got the power supply, and then we're going to actually have the preamplifier that shapes the overall tone, the sound of the circuit. Then we're going to have our power amp section, which is going to take the signal that we feed it from the preamp, and is going to make it loud enough and powerful enough to drive a speaker. So we're going to talk about the transformers, the power transformer, the output transformer, the power amp, the preamp, and how all of that relates to each other. So let's start off here over at the beginning of the circuit. This is actually the plug that goes into the wall, and that in the United States is going to carry about 120 volts AC. An AC signal is like a sine wave. It changes over time. It goes between plus and minus, like a positive voltage and a negative voltage. This is what our wall outlets are versus a DC voltage would be like what is on a battery, for example. Like it's just a steady 9 volts, for example. So over here, we're starting off with our wall plug that back then was a 2-prong wall plug. Today, of course, we would use 3-prong and wire this a little differently, but let's not make it too complicated today. This is the voltage coming in here, and we're going to go through an AC switch. It's just a switch, and what that's going to do is it's going to break the connection from that wire coming from the plug that feeds into this right here. This symbol is a transformer. This one happens to be the power transformer. The other wire here coming from the wall plug is going to go into a 2 amp fuse and then into one of the infamous death caps. But this one has a fuse on it, so it's not the worst thing in the world, but definitely not something we're going to be keeping. If you want to know more about what the death cap is and the issues about that, I suggest you look up Uncle Doug's video on YouTube. He does a great job explaining what that's all about. So that brings us here to the power transformer. We're feeding in 120 volts AC, and what a power transformer does is it pretty much does exactly what its name implies. It transforms voltage, one voltage, to another voltage. So basically what we're going to do here, let's create a new layer and move over here to the secondary side of the power transformer, and we'll talk about what's going on. We've got a few different parts here. All right, so the leads we got coming from the power transformer down here, these are all the different taps off the transformer. So it's going to take that 120, and then on this tap, it's going to change it to 6.3 volts AC. We're going to be replacing this with a modern transformer that has a center tap, but I mean, this is all kind of the same concept. That's 6.3 volts that go to the heaters of all the vacuum tubes. That's what makes the tubes themselves actually light up and glow. That is the actual heater. 6.3 volts, it's because vacuum tubes are thermionic devices, meaning they react to heat, and they have to be a certain temperature for the electrons to flow properly. Going up to the next set of taps here, this is going to be... All right, let's move up to this middle section right here. This is going to be our high voltage taps on the secondary side of the power transformer. So it's going to take this 120, and then it's going to convert it up to about 325 volts to ground. Right here's ground, and then 325. So if you measured across the two outer wires, you would get 650 volts AC. This is center tap, so when it's referenced to ground, we get 325 on each side. Then we're going to feed that into a 5Y3 tube rectifier. Tube rectifier, what that does is it's going to take the AC voltage that's going up and down, and it's going to take the negative parts of the sine wave and it's going to flip them upward, making these big humps that are all positive. If you want to learn the details of that, just read about or look up diode rectifiers in power supplies. So it's just a little electronics trick, and that is what the function of the 5Y3 tube rectifier is. And then these upper taps up here, that is the 5-volt heater tap that the tube rectifiers need. For whatever reason, tube rectifiers use 5 volts AC for their heater lines, while all the 6.3 volt tubes for the audio portion of the circuit use 6.3 volts. So that is the basics of the power supply. So we go from 120 down to 6 to heat up all the tubes, down to 5 to power like the heaters of the rectifier tube, and then up to a high voltage, which is going to be our actual high voltage power supply for the audio portion of the amp. The audio portion of the amp needs to run on DC voltage, which is direct current. Remember we said AC voltage is like what comes out of the wall and it oscillates between positive and negative. DC voltage stays at a fixed point. So we converted this up to about 325 volts, and then we rectified it so it's making these humps. And then what happens is these 1, 2, 3 are the filter caps in the power supply. Whenever you hear about people talking about discharging filter caps, otherwise you'll get hurt when you're working on an amp, that's what they're talking about right here. So what capacitors do is they store a charge. And without going into too much detail, what this is all going to do right here, let's add a new layer. And let's make this part. I wanted to make it green, but that seems confusing because people usually associate green with ground. This is our filter cap section right here. We're going to make it blue. And what it's going to do is it's going to smooth out that AC voltage through these caps by storing a charge on them and then running them through a couple resistors. They're filters. They're going to filter out that 60 cycle frequency and make it a DC power supply. So when we're all done here, we're going to be running at, let's say, about 350 volts, and then they're going to drop as we go down the line. This first point here, the highest voltage runs to the output transformer, which also works to filter the power supply, and into the output tube, which is a 6V6 GT on the plate. So that's where we get the voltage for the power amp. The screen grid of the power amp tube is powered off a different node right here. And then when we come down one more node, as they're called, like this is like an area that's all connected, separated from that one there, is where the tubes, the preamp tubes, are actually going to get their power from. So they run through a 100K load resistor is what they're called. They follow over here, 100K load resistor to the plate of each of these 12 AX7 vacuum tubes. So that is basically how we go from AC on the wall. We convert the voltages to what we need through the power transformer. And then from there, we smooth out that AC power and make a DC power supply over here. And then now let's go ahead and go through the audio path. Let's pick a color for the audio path. All right, here's our two inputs here. One of them is a high input, one of them is a low input. Let's see if we can figure this out. It's a three-prong jack. It's a TRS jack, so that's the ground, that's the ring, that's the tip, our signal. If we go through this way, let's see if we can figure this out. If we look at this one, the ring here is connected to ground. When there's no jack in this input, when there's no cable in this input, the tip connects to the ring. That's how these switching jacks work. So if the tip is connected to the ring and there's nothing plugged in, right here is actually connected to ground. So if we plug in the input 2, we're going to go through a 68K resistor and then another 68K to ground. So this will cut our signal exactly in half. It'll be a low impedance input, which sounds a little bit different when it runs into the screen. I'm sorry, that is the grid of the vacuum tube. Yeah, my mistake. So those run into the grid of the vacuum tube of the 12AX7. That is the input in this scenario. You can wire tubes in different ways, but this is wired as an amplifier stage. So that's where the input goes in. If we plug into this input, let's analyze. Let's imagine there's nothing plugged into input 2. So the tip is connected to the ring, but the ring is not connected to ground. It's connected over here. So that just basically puts this path in parallel with that path. Nothing goes to ground. So if we're looking in from the input, we'll see a 1 meg impedance to ground. And then these two paths will be in parallel, so that will turn into a 34K. Look up parallel resistors to calculate the resistor value if you'd like to know more details about the math on that. So that is going to be our high input, which does not cut our signal in half, and it's going to be a lot louder and have a very high impedance versus a low one. All right, this is the cathode of 12AX7 number 1. It runs through a 1.5K resistor to ground. Between the power coming in here, the high voltage, let's say it's 300 volts DC roughly, through the 100K plate load resistor, there's going to be current flowing through the tube going this way to ground. When current flows across the resistor, it causes a voltage drop. Long story short, this resistor and this resistor working together help to, well, they don't help, they bias that vacuum tube. So we're going to come in, let's just, I think that kind of primes you for what we're going to be talking about and thinking about as we walk through the audio path. Let's start here. It doesn't really matter which input we go through, but we're going to come in through here to the grid of 12AX7 number 1. And then the audio comes out of the plate right here. And it goes through this coupling cap right here. This cap is going to remove the DC voltage because there is DC voltage right here, right? A couple hundred volts. DC voltage can't get through a cap. So over here, it's stripping away the DC voltage. So we just have our pure audio signal again, runs through here. This is a volume control. Turn it all the way up. It's max volume, turn all the way down. It kills the signal. We're going to run into another gain stage, 12AX7. Same scenario here. It's biased up. It's got a 100K load resistor, 1.5K, or they're marking it here, 1,500 ohms on the cathode bypass resistor. And they got one other thing going on here. There is negative feedback coming from the output, but why don't we just deal with that when we get to the output, huh? When two wires cross in the schematic and there's no dot, it's because they're not actually connected. It's just how we have to draw things. Like here's a dot, so they're connected. This is not connected right there, the negative feedback path. So out of plate number 2, this is audio again, AC audio signal, but with a DC voltage on it. We're going to pull the same trick and throw a coupling cap on it to remove the AC voltage. Remove the DC voltage from right here, right? And we're going to keep the AC audio signal. We don't want DC voltage there because it basically fucks up the bias of the tube. You can't have that. You do not have positive voltage on the grid of a vacuum tube. It will destroy them. So it's just kind of part of tube amp design. So we stripped off the DC voltage that tube needs to run and amplify the signal, and we kept the audio signal running in. Again, okay, we're at the power tube right now. Got a very similar scenario, but instead of a 100K load resistor, we're getting our power, which we're getting our power on this one through here. I'm going to go ahead and mark these over here too, so you kind of get an idea of what's going on. That baby blue's the DC voltage. Okay, similar scenario. We're grabbing our power from here. Instead of a 100K load resistor, we use the output transformer. That's another whole lecture in a video. If you want to look that up, you sure can. It's a single-ended output transformer. DC voltage runs through here to power the tube. And then we also get, where did that purple go? We also get audio, just like in the previous stages, passing out the plate. Then it's going to pass through the output transformer and through the speaker, making sound, as you can see there. All right, so that's the audio path of the amplifier. Why don't we... Why don't we talk about what's going on here really quick? So this is the output transformer here in the light green. Tube power amp stages, without explaining the meaning of everything, they need to have a certain load that they drive, and they like to have a high impedance load, like 7,000 ohms, for example, on this style amplifier, roughly speaking. Speakers are not made in configurations where they have 7,000 ohm speakers. It's just not how the world works. So this device wants to see 7,000 ohms, roughly, and then the speakers that we make and get off the shelves at Speaker World, an imaginary store I just made up, they only come in like 4, 8, 16, 32 ohms. So what we need to do is use a transformer again. Transformers can transform voltages to other voltages, but they also have this amazing thing where they can transform impedances to another impedance. So the way this works is it takes an 8 ohm speaker and transforms the impedance to where on this side of the transformer it looks like 7,000 ohms, for example, which makes this vacuum tube happy. And it makes our amp not self-destruct. I'm trying to look here and figure out what else we're missing. All right, some of the audio signal here from the output of the actual speaker, it gets pushed back through this way. It runs through a 22K ohm resistor. And then it runs down here and then into the cathode of this last vacuum tube. That's what's called negative feedback. What it is this signal is out of phase with that signal, 180 degrees. So we bleed off some of the output signal back to here, and they cancel each other out. Basically what this is the more, imagine if it's a car, the more gas you give it on the pedal, the more the sensor is going to feel it and then correct what you are doing. You can also think of it like anti-lock brakes or something. It's taking a reading from over here and then passing it back to another part of the circuit to help control what's going on. If you cut that resistor, it's going to get a lot more aggressive sounding. If you lower the value, it's going to be a lot cleaner sounding. So that is what negative feedback, and it's kind of a self-correction type of thing. All right, that is video 2. I hope that kind of gives you a primer into how tube amplifiers work. They're always broken. I always think of them in different sections, right? You got your AC electricity from the wall and on the heaters of all the tubes. So that's one section of the amp. Then you have your high voltage AC section over here that needs to be rectified to turn into a DC voltage. So we use a rectifier of some type to turn an AC alternating current into a AC current. Well, we take all of the negative portions of the AC current and flip them upwards to make them positives, like little mountains. We use filtering with resistors and caps, RC filters, rated at a high voltage to smooth that out to a DC power supply to power the preamp tubes and the power amp tube. We use an output transformer to impedance match the output section to the speakers we want to use. We run our signal into the input of a preamp to help shape the sound. We usually have volume controls, tone controls, and other amps. This one's very simple, just single volume control. Before we run it into a power amp section that takes what we did and makes it very powerful and loud so that we can drive a speaker. This amp here is good for about 5 watts, and I look forward to hearing this one when it's all done. So if you got questions, drop them in the comments. I'll be back in the next video, and we're going to actually get to work on this. I think we're going to start by picking out what type of power transformer we're going to get, output transformer. I'm going to upgrade those, mercury magnetics most likely, and a few other parts. So I'll see you in the next video.